Okay, let's dive right into this explainer. Today we're mapping out exactly where the world's water resides, from those massive, seemingly endless oceans down to the very tiniest trickles. If you've ever just spun a globe and marveled at all that blue, you already know water covers a huge amount of our planet. But how is it actually distributed? Well, the answer is probably a lot more extreme than you might think. We're going to lay out the data so you can get a really clear picture of Earth's surprisingly imbalanced water inventory. Right away, you can see how the overwhelming abundance of salt water just completely dominates everything else. It leaves us with this incredibly tiny sliver of fresh water that we actually rely on day to day. Literally, almost the entire distribution belongs to a single category. All those freshwater sources that sustain land-based life, our agriculture, our industries, they're all squeezed into that tiny, almost invisible remaining fraction. To make sense of all this, we're going to follow a shrinking drop journey today. We'll be covering 1. The dominance of oceans. 2. Glaciers and hidden aquifers. 3. Lakes, rivers, and ponds. And 4. Rainfall and natural springs. Let's kick things off with Section 1, the dominance of oceans, the planet's massive reservoir. So, the crucial takeaway here is this absolutely staggering number, 97%. Roughly 97% of all the water on the planet is held in our oceans. Just pause and think about that for a second. If you took all the water on Earth and scooped it into 100 buckets, 97 of those buckets would be filled to the brim with undrinkable salt water. And that 97% is sprawled entirely across the globe. These massive bodies of surface water interconnect, they surround our continents, and they act as the absolute dominant feature of our planet's geography. Now, this massive volume is officially divided up among 5 distinct oceans: the Pacific, Atlantic, Indian, Arctic, and the Southern or Antarctic Ocean. Together, they make up the vast, vast majority of surface water on Earth. They dictate our weather patterns, and they support completely separate ecosystems from anything we experience on land. Moving right along to Section 2, glaciers and hidden aquifers, Earth's frozen and buried reserves. We take a dramatic plunge here, dropping from 97% all the way down to just 2% of the planet's water. Now, this 2% does represent fresh water, which sounds great, but there's a huge catch. It's locked away in frozen form. These glaciers and ice caps are mostly tucked away at really high elevations and up near the North and South poles. Basically, areas where snow accumulates over super long periods without ever melting. The source data points out that these frozen reserves store more than a third of the Earth's fresh water, which essentially keeps it entirely out of circulation for immediate human or biological use. Shrinking our drop even further, we hit 0.9%. We're at a fraction of a percent now. We can't even see this water from the surface, yet it is absolutely critical for global survival. Before we get into where they are, we really need to understand what they are. Aquifers are subsurface water sources. They are hidden, underground reserves of water. And just to be clear, they aren't like rushing underground rivers. It's more like porous rock, sand, or gravel that holds water beneath the planet's surface, almost like a giant sponge. Hidden entirely from our view are these massive subterranean networks. They stretch from the high plains in North America to the Great Artesian Basin in Australia, and they sprawl right across parts of the Arabian Peninsula and northern Africa. Together, these unseen vaults hold that crucial 0.9% of all the water on the planet. All right, let's jump to Section 3, lakes, rivers, and ponds, the surface water we see. This is truly mind-boggling when you stop to think about it. Every massive lake you've ever seen, swam in, or heard of, all combined, makes up only 0.008% of the planet's water. That is 0.008 of 1%. Yet they feel so incredibly prominent to us, right? From the sprawling Great Lakes in North America to Lake Victoria in Africa and Lake Baikal in Asia. Interestingly, our source points out that these bodies mostly form when precipitation or rivers accumulate in depressions on the Earth's surface. Sometimes, they even form in areas where groundwater seeps up from the water table. But on a global scale, their volume is just incredibly minor. Now prepare yourself for a truly tiny decimal. Rivers, those raging, powerful forces of nature that literally carve canyons and define national borders, they contain a microscopic 0.0002% of all water on the planet.
But despite being just 0.0002%, these natural pathways of flowing rainwater and melted snow, like the mighty River Nile and River Indus, are absolutely vital. Flowing from higher to lower elevations, they act like the planet's circulatory system, ultimately discharging their water back into the oceans, seas, and lakes.
And if you're wondering where ponds fit into this tiny, tiny fraction, the distinction is actually pretty clear. While lakes are larger and deeper, ponds are generally smaller surface water sources. Some occur naturally and rely really heavily on rainfall, while others are entirely man-made. Because they're smaller and way more accessible, pond water is often utilized directly for our human needs, like agriculture, irrigation, fishing, and landscaping.
Finally, let's explore Section 4, Rainfall and Natural Springs, the replenishers.
So how do these vital surface and subsurface systems recharge? Well, rainfall is one of the absolute most important sources of water, especially for agriculture in arid regions. It's highly seasonal, sure, but its global distribution across different geographic zones is actually quite shocking. What's genuinely surprising here is the drastic geographic imbalance. A massive two-thirds of all rain falls strictly along the equator. That leaves the rest of the entire world to share the remaining one-third. This naturally creates those incredibly wet tropical zones you hear about and vastly dry regions elsewhere, which really drives the need for careful water management. Another fascinating replenishing source is the natural spring, bubbling right up to the surface. These happen when the water table is located close to the Earth's surface, or when underground streams from those aquifers we talked about literally break through the rock and soil to see daylight. And whether you're dipping into a freezing cold natural spring or relaxing in a hot spring, that entirely depends on the local geology. Our source notes that springs located in regions with volcanoes produce hot water naturally heated by geothermal energy. On the flip side, springs found in areas with absolutely no volcanic activity produce cold water. So let's just take a step back and look at the whole picture. We started at 97% in the massive oceans. We dropped to 2% locked away in ice. And we shrank all the way down to tiny fractions of a percent for the rivers, lakes, and aquifers we desperately depend on. It really leaves us with a critical question to end on. Knowing just how incredibly scarce our accessible surface freshwater truly is, what steps must we take in our communities to protect and manage it? Think about that shrinking drop for a while, and I'll see you in the next explainer.